Hello, guys. Good evening, and welcome to Chinta's department. Let's start the class, okay? So let other people join, and we'll soon start solving some interesting problems today. Yeah. I'm just waiting for the people to join. So I'll just start the class in just a minute, okay? Don't worry about that. Hmm. Okay. Let's start. Good evening, all of you. So today, we are focusing a bit on algebra version. So let's see how you can solve this equation. Um, okay, so let's do this problem. It's a quadratic equation problem, and how we can form new quadratic equations from the given quadratic equations. Okay, so oops, just give me a minute. Yeah, here it goes. The first problem for today. So it asks you that no, there is no meeting to join. We the IOQM session, like the when it will be occurring, I don't know. It's not being announced yet. So let's focus on the problems, okay? So first of all, we are going to focus on this problem on algebra. So let's see how we can attempt this problem. So we have to find all the values of x for which the roots of the equation. I mean x, like you have to essentially find the roots of the equation x square plus 5x plus x, which is really easy, and the roots are -3 and -2. You can easily solve it by middle term factorization or whatever. Like you can easily solve it by Sudhachija method too. So it's not really hard to understand that. So the main aspect of this problem revolves around the fact that how the equation change when we take like a function of the given roots. Okay, how the equation changes. So here the roots are x. It's you can write as x plus 2 into x plus 3. So the roots are -2 and -3. So that it's done. Okay. The next question asks that each of the roots are increased by 7. So I mean the roots of this increased by 7. What is the new roots? Okay, and it's very simple. That the new roots by you can use a fundamental theorem of algebra in this case, that therefore the new roots are -2 plus 7, that is 5, and -3 plus 7, that is 4. So it's x minus 5 and x minus 4, which leads to x square minus 9x plus 20. Okay, that's also simple. So the next question asks you that the roots of this equation are now increased by 1. Find the equation that has these new numbers as roots. So what will you do in this case? It's really easy. You first, what will you do in this case? It's a very easy problem. I started with an easy problem. So what will you do in this case, guys? Think about it. Sure. Srinivasa Devarakonda. You are using the fundamental theory of algebra to show that if p is a root of an equation, then x minus p is like a factor of that. You can get it by remainder theorem and factor theorem. So you need to know these results before coming to this class. We are studying this in our algebra course. Yeah. So these are the things you must be very sure about. Okay. Um, so go, if not, then please go back to your algebra module, and then like you can see the recording of this of this lecture once again. So then let's try to find out this roots. The new roots are really easy over here. It's x minus 4 times 3x minus. How will you factorize it? You can easily factorize it in this format. I think it's x minus, I'm not sure, x plus 2 into x minus 1, I guess. Yeah. So the roots are x minus 4 times 3x plus 2, that is minus 2 by 3, and 1 is over there. That is very intuitive. So these are the roots 4, minus 2 by 3, and 1. So these are increased by 1. So you get 5, 1 by 3, and 2. So therefore the new roots will be, new equation will be x minus 5 times x minus 1 by 3 times x minus 2. And it's a very basic, easy exercise to expand this in form of a algebraic, terms of x. So that is really easy. This is a very easy problem. So we should not spend more time on this. I think it's really quite easy to solve. So let's move on to a harder problem. Um, what we can do? Okay, 0, 0, m 0, 6. Okay. Uh, okay, this is an interesting problem. I like this problem. Let's do this problem. The diagram is a bit it's a bit blurred. The question asks you that, yeah, exactly. The question asks you that the triangle OMN is a triangle in the plane, okay, in the 2D plane, where O is the origin. So let me write it over here again. O is the origin, which is 0, 0. N is 0, 6, and M is 6, 0. So we have to find this point PAB. What are the possible coordinates of this P, which is AB, inside this triangle OMN, such that the area of the triangles POM is equal to area of triangle PON is equal to area of triangle PMN. It's a really interesting problem. So P is a point inside the triangle OMN, such that area of triangle OPN, PON, POM, and these three triangles that are formed, 1, 2, 3, all of the areas are equal. It's a really interesting problem. Circumcenter, yeah, circumcenter. That is a very interesting choice, of course. But circumcenter के लिए, here you understand the circumcenter of a right angle triangle is on the hypotenuse. Okay. I hope you know that, because this is equal to this equal to this. So therefore the area will not be equal, because one of the areas will be 0. So therefore circumcenter is not the solution over here. The first, I will ask you some questions. The first question is that, is P unique? What do you think? Is P unique? Is P unique? So that's a very interesting question. So what do you think, guys? Is P unique or not? Centroid in center. Various people are like suggesting various things, but okay. Centroid. But for centroid, the area is okay. That makes sense. In center, yeah, you need coordinate geometry. Of course, you need coordinate geometry. Yeah, but you can also do it by some other method if you want to. But coordinate geometry will make it easier. How? So let's sort of first compute all these areas, okay, in terms of A and B. Let's try to try to compute this. It's very easy. So let's first compute PON, triangle PON. What do you think is the area? What do you think is the area? The question is the following. In a triangle OMN are given. I think it's 8 comma. Oh, I think it's 0 comma 8. It's 6 comma 0. Okay. You have to find the coordinate P such that the three triangles form OPN, PONM, and OPM are all the areas are equal. So tell me this. So therefore, I'm trying to find out the area of PON. PON area is what? If this is AB, so this distance is what? A, right? And this distance is 8. So it's half into 8 into A, right? Let's try to find out POM similarly. POM similarly. Exactly. That's the beauty of coordinate geometry. OPM is this height is B because it's P of A comma B. This and its base is 6. It's half into PMN is what? Is half. So do you know this side? The hypotenuse is very easy by 6. So it's half into 10 into what? Half into 10 into what? Distance from a point to a straight. Revise that. So given a coordinate, if it's A comma B and the line is say x by m plus, we're calculating the trying to calculate of the total area, right? So AMN area is what? Half into 6 into 8, 24. So it will be 8. So we don't need to know this. We just need to equate this to this. 2 and B is equal to 8 by 3. Very easy stuff, right? There's only one point for which it is being equal. Okay, did you understand the easy stuff? So that's the basic idea. So we don't need any formulas or stuff like that. It's really easy. Okay, guys, no formulas, only basic mathematics. So now my question is to you guys, is that why do you think such a point is unique? Why do you think such a point is unique? So I am trying to extend this problem, okay? So I have two extensions. Thing is that if one of this point, so if one of this point varies, how will this point vary? And what is the speciality of this point? So I'm quite curious about this. What is the speciality of this point? Does that all the 3 points are like all of them are correspondingly all of them are divided in equal areas? What do you think? What is the speciality of this point? It's 2 comma B 8 by 3 I think you can easily get it. I think you have got it. Why this, sir? Okay, another question to you guys. Another question to you. You have already proved. Someone has told it. Yeah, I think someone has told. Lovely, Shobrodipto. So it's actually the centroid. Now, can you prove it's actually the centroid? That's the idea. It's actually the centroid. You're totally correct. Now, my question is, can you prove it's actually the centroid? So it's a very interesting question. Can you prove it's actually the centroid? So we have a triangle, and we are looking for a point inside the triangle, such that all the three areas are equal. Okay, so mathematically it's turning out, I mean, we have seen that actually we have found out that point. Now the question is that, can you prove it's actually the centroid? It's a very beautiful question. It's dividing the ratio 2:1. Okay, how are you proving that, Nijhar? So we are trying to prove that that point, that special point P, is actually the centroid. We're taking a point which bisects OM. Where is OM? Okay, we are taking a point which bisects OM. Yeah, we have understood this A plus B plus C by 3. What is Thell's theorem? No, we know A and B. See, Nijhar. I'm trying to generalize this problem to a general problem, okay? It's a right angle triangle problem given over here. I'm trying to generalize the problem. My problem is now the following. My problem is now the following. Let's say it's a random triangle over here, okay? And I am looking for a point such that all the three I'm looking for a point such that all the three triangles have equal area. Looking for a point so that all the three triangles have equal area. Now my conjecture is that P is centroid of triangle ABC. Is it true or not? Find distance between N and the point. Okay, so Ananta, we are trying to understand in a general framework. Okay, so trying to find that point P in this general framework ABC, this triangle ABC. Yeah. So we are trying to extend the problem. See, we never stop at a single problem. Okay, that should be never in your habit. You should always explore the problem to your best, how much you can. Okay, so we are generalizing the problem to the fullest. So that's where the exploration comes up. That's where the adventure comes up in solving problems. So that's the question. ABC is a triangle. P is such a point where triangle ABP is equal to triangle. This area is equal to triangle APC is equal to triangle BPC. Any ideas? So I have a question for you. So do you know? So suppose my question is that, suppose can there so I have two questions. Is P unique? Can you prove that P is unique? Can you prove that P is unique over here? So always whenever you study mathematics or solve problems, never sit with a closed mind, okay? So whenever doing a problem, always think about how you can extend the problem. So it will become your problem, and then it will become your solution. Maybe that problem can become an unsolved problem that you have solved in the future. Yeah, so that's can you prove that P is unique? That's the first step. Can you prove that P is unique? It's very easy. Suppose say P is not unique. Okay, so then there exists a P dash जिसके लिए this two are equal, right? Suppose say P dash इसके लिए this two are equal. Okay, three lines. Which triangle? No, I am fixing ABC. Shubhradipto. Three lines cannot intersect at more than one point. Yeah, it's true, but how is it helping in this solution? So suppose P dash is such a point such that this is similarly hold. Now understand the beauty of this. Understand that, now observe that this is equal to triangle. All of these are equal. That means it's equal to ABC ka by 3. All of them are equal. Similarly, if P dash is such a point, then APB dash, APP dash equal to triangle BP dash C is equal to triangle, what is that? Is, wait, I think I missed some. Yeah, ACP dash is equal to again ABC by 3. So observe that all these three have equal area. Okay, all these three have equal area. So ABP and ABP dash have equal area. So when it can happen, it has the same base. It can happen if only it has the same height. So therefore, P dash and P must, this line must be a parallel line to AB. Okay, that makes a lot of sense, right? Because its height is equal, must be equal. Similarly, P dash, this line must be parallel to. So what we are getting? P dash is parallel to AB. P dash must be parallel to BC, and P dash is parallel to AC. It's asking that if it can happen that two points are there such that it is parallel to each of these three sides, then it can happen. Now, can it ever happen? Tell me. It can never happen. It can never happen because if P dash is parallel to AB, it must be cutting this B and C. So it can never be parallel to BC, right? So it can never happen. So P and P dash must be equal. Yes. So that's the beautiful aspect of this problem. So understand this. If P dash is parallel to AB, it must cut the line BC. And if it must cut the line BC, it means that P dash can never be parallel to BC. But we want that P dash must be parallel to BC. Also, we can solve by this. If P dash is like this, then observe that for some P, it like BP will be inside BP dash C, which means that BP dash C, like BP dash C has a greater area than BPC, which is not possible. So therefore, P and P dash must be equal. So understand that P is unique. Now what will we do? We want to prove that P is a centroid. So, and we know that if P is a centroid, if P is a centroid, this is true. We know if P is a centroid, then this happens, of course, because this is a area of median. Like we can easily prove that these three are equal, right? You can easily prove that for a median. So therefore, for a centroid, so therefore P must be the centroid. It's unique, and there is a point which satisfies that property. So it's a centroid. It's the centroid. Sorry. Okay, WhatsApp group. So this is a very beautiful problem. And see, I have never planned this problem out for you. It just came up naturally because whenever I solve a problem, I never stop at a problem. I try to explore the problem for you. Okay. So, and that's also how you should learn and try to solve problems. Never stay bounded in your problems. Okay. Just explore the new problems that you can make out of this problem. So therefore, we have that it is true for a general triangle too. That's it. So beautiful problem. So let's move on to this next problem, similarly like this. Any doubts any doubts, guys? Prove that which three areas are equal, Ananta? Which are you talking about? Can you tell me? Last figure? Oh, for median? For median, you want me to prove that if the area is are equal? Areas are equal? Huh? Okay. So yeah, sure, I will prove it for you. So yeah, it's a very interesting aspect. Just give me a moment. Let me search from such diagrams. Centroid, median. Yeah, I've got a diagram for you. Let me use that. Oops, what is this? So we have got this diagram over here, and let's try to understand this. That if this is a centroid and we have this all this over here, okay? We have all this over here. It's a scalene triangle, yeah. And this is a centroid. So to understand this, since it's a centroid, then let's mark this, okay? Let's call this A, B, C, D, E, F. Observe that A plus B plus C equal to D plus E plus F, right? A plus B plus C. Oops, it's not transparent. How can I make it transparent? Can I make it transparent? Yeah. This part is actually equal to this part. Very bad sort of marking. And similarly, what we have that A plus B plus F is equal to C plus D plus E. Or let's say, oops, A plus B plus F. Oh, no, sorry. Now also observe that this is a median. Oh, it's very easy now. So also observe that C and D must be equal. C and D must be equal. So let's C and D must be equal because this is also the median of this triangle. So therefore, this is also equal to C. This is also equal to A. This is also equal to say E. A C C E E. Lovely. So now observe that what is so it's twice A plus C. So now we will prove that A is equal to E and A is equal to C also. So let's see how we can prove it. So we have that twice A plus C is equal to twice E plus C. You observe it? Twice A plus C is equal to, therefore we have that A is equal to E. So we can replace that and we have that A is equal to E, so this is equal to A. And similarly we can use this now. Thrice A is equal to twice C plus A, which implies that A is equal to C. So you get all these 6 triangles are equal. And we get that therefore this is equal to this is the point that this is equal to twice A, this is equal to twice A, that is equal to twice A. So therefore we get the solutions. Okay? Did you understand, guys? Any doubts? So we use the basic definitions of median to understand and solve the problem. Yeah. Did you understand, guys? Any doubts? So if a point uniquely divides the whole triangle into 3 distinct areas, 3 equal areas, that point must be the centroid. Okay, lovely. Okay, so let's move ahead to the next problem. Not next problem, but extension of this problem. So what is the extension of this problem? Is that now instead of doing this in a triangle, we will try to do this in a quadrilateral. So what is the question over here? So let's see the question. Let's see the question over here. The question asks you that the diagram quadrilateral O, okay, this is a very bad blurred image. I don't even understand which is O, which is whatever. O, this is 0, 0, M, that is 6, 0, K, that is 0, T, and L, that is 10, T, the same height. And this Q is some A, B, or say whatever, A, B, or C, D. Does that all these 3 area, all the 4 areas are equal? So now the question is that you have to show that no such point exists. Okay, this is an interesting aspect of it. No such point exists. In case of a triangle, there is such a point, but do you know of such a beautiful point in a quadrilateral? That's an important idea to explore. Do you know of such a point in a quadrilateral? Think about it. Think about it. Do you know of such a point in a quadrilateral or not? And why do you think it doesn't exist? Why do you think it doesn't exist? It doesn't exist. Okay, so think about it. Why do you think it doesn't exist? We can easily solve problems, so easily solve the same equation over here and see why it doesn't exist. But the next question that we should understand is that why it doesn't exist. So it's the base is T over here, the base is 6 over here. Okay, we don't know about this base or this base, but yeah, we can easily find out the area of this triangle, I guess, of this quadrilateral, I guess. Okay, because it's a trapezium. Yeah, that's why. So the area of the whole thing is what? A, B, C, D, and it's equal to it's not ABCD, it's actually equal to OMLK. It's a trapezium. This height is 10, this is T height, this is 10, so it's half into T into 16, that is 8T, and we're dividing into 4 equal areas, so each of this is 2T. So let's take the area of the triangle QOK, that is this one. This is one set. QOK is half into the height is C into T is equal to 2T. So we get that C must be equal to 4. Similarly, let's take the other triangle, triangle 2. Triangle 2 के लिए its area of triangle QOM, it's half into D into 6 is equal to again 2T. So we get that D is equal to 2 by 3 into T. Okay, that makes sense. So we got this. So now we got the values of D and C. Okay, we got the values of D and C. What's next? You can also do it for this point, this triangle, this triangle. How? This 3. For 3, say it's triangle KQL is equal to half into 10 into height is what? T minus what? Into T minus the total height minus this height, that is D. T minus D is equal to what? Is equal to again 2T. Okay, so let's call it 5. So we have that, therefore 2T by 5 is equal to T minus D. So we get over here is that D is equal to 3T by 5. So we get two equations of D. D is equal to 2T by 3, 2. Therefore it implies that T must be equal to 0, which implies that the height is 0. Okay, that means the quadrilateral doesn't exist. So therefore we get that there such a point doesn't exist. Okay, there such a point doesn't exist. It's a beautiful problem, beautiful solution, right? But my question is the next, that can we prove it for a general triangle, or is it always true? For example, it is not always true. For a square, we get such a point, the intersection point of the diagonals, it equals, therefore there exist certain quadrilaterals for which it exists. There doesn't exist certain quadrilaterals for which it doesn't exist. There does exist some quadrilateral for which it doesn't exist such a point. So my question is that what are such quadrilaterals for which it exists? So we of course know if such a point exists, that must be unique, using the same principle and ideas. Okay, if such a point exists, that must be unique. We know that. If such a point exists, that must be unique, using the same proof idea. The next question is that when such a point exists, yeah, when such a point exists. Think about this. Now it's trapezium just for the sake of the easiness of the proof. But we are not restricting ourselves to trapeziums. We'll be restricting to higher possibilities. So parallelogram, square, rectangle, maybe it's true, maybe it's true. Is it true for parallelogram? I don't think so. Is it true for parallelogram? Rectangle के लिए is it true? I'm also not sure. And parallelogram does exist? Let's try to understand. Let's try to see if there is exists for a parallelogram or not. For a parallelogram, let's try to see. Let's try to see for this parallelogram. Such a point exists such that it equally divides. I'm not sure actually. My God, let's see first if there exists for a rectangle actually. Such a point exists for a rectangle. So let's say this height is x, this is x, and this height is y. This is a, say this side is b. So this is b minus y, a minus y, and this is the I think it exists for rectangle, or maybe not. I don't know. So if this two exist, we understand a must be the y must be a by 2. That's for sure. And if you understand that this if this two exist, then this must be b by 2. That's for sure. The height must be b by 4 because these two must be equal. But thing is that this half, oh yeah, it exists. The intersection point of the diagonals, it exists. Yeah. Half a by 2 into, yeah, it exists. So for parallelogram, for rectangle, it exists. I think it also similarly exists for a parallelogram. Because I think it's just a shifting of the parallelogram. So similarly, we can shift the whole parallelogram like this. Like this. And how will this shift? It must similarly lie in between at the height midpoint. Now, where it exists is the idea. Let's try to do it for a parallelogram. Let's try to do it for a parallelogram. So let's say it is such a point. And of course, we know that the height must be in the midway. Let's say it's a height, so it must be h by 2, h by 2. I'm got curious that what is this distance rather? Does it really exist for this? So if it's in the midway, of course, this two height must be equal. The thing is that, I mean, if this two height, this must be equal to this, okay. This must be equal to this, then the height must be equal. If the height is equal, then I think these two distances must be equal too. So the thing is that it can happen only in the intersection point of the diagonals. In the intersection point of the diagonals, is this two are the two areas equal? I'm not sure about that. The question is that when you have this corresponding thing, when you just shift it, does the area change or not? Just give me a moment to think. Okay, so yeah, for that also I think that it must be, yeah. No, we can use it in a simpler idea, okay? So how we can show that, so this is the idea, I will just tell you how I did it. So this is a rectangle, okay? I will make a similar, Okay, I will just make it a different color. Okay, so we shifted this. So essentially, let's understand. We will do it in a very geometrical manner, like this. Say, and let's another one. This was the initial point. Okay, this was the initial point of intersection. Now it shifted to a different stuff. This one. Let's take a different color. Let's take this. Now it shifts. Oops, 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 oops. Bigger one. Now it shifted to this. Okay. So now this point is shifted to this point. So if this such a point exists, it must be this. And observe these two triangles are equal length. I mean, these two triangles have equal areas. So observe that this area and this area are equal because they have the same height and the same base. Time to prove that these two areas must have equal areas and this two area must have equal areas, of course, because of the symmetry. We can usually prove it. This is equal to this and this is equal to this. So it's these are all congruent. So these two areas must be equal. So let's say this area is A, this area is B, and this area is B, and this area is B. So we need to prove that whether this B is equal to A or not. That's the idea. And B must be equal to A because this is a median. So this must be A. So these all are equal. Okay. Yes, you're right. Lovely. So yeah, you're right. So essentially, it divides into 4 equal areas. We can also be understood by the medians. Yeah, I did a longer way. So we have shown it exists for a parallelogram. Similarly, hence it exists for any rectangle. Okay, it exists for a parallelogram. Hence it exists for any other rectangles and stuff like that. Does it exist for a trapezium? That's the next question. Does it exist for a trapezium? I'm not sure about this though. It will not exist for trapezium. We have understood over here. We have seen over here. It doesn't exist for trapezium. You have seen an example over here. So what are the conditions that are required for this to have equal areas? Such a point exists. When such a point will exist? When such a point will exist? I'm quite curious. I think such a point will only exist if the diagonal bisect each other. Can we prove that? So my claim is that such a point will only exist if the diagonal bisect each other. I'm not sure about this. No, my claim is this, that see, in case of isosceles triangle, isosceles trapezium also, the diagonal bisect each other. Let's see, or is it does it bisect each other? Let's see. Isosceles trapezium also, the diagonal bisect each other, or is it? The diagonal, no, the diagonal doesn't bisect each other. Okay, so let's take for a general quadrilateral. Let's take a general quadrilateral. Let's say this A, B, C, D. So we are trying to find a point P such that all these are equal areas. All of them are of equal areas. Okay, that makes sense. So can we prove? Okay, 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 okay. I got this idea. Okay. So I really got this idea. Let's share with you. I'm not sure whether it will be true or not. So what we're trying to find, let's take this. Let's with respect to this. Okay. So we are trying to find a point P such that APC has area same as BPC. That is, these two heights must be equal. Okay, these two heights must be equal. Similarly, let's take DP. For DPC, so for ADP must be equal to DPC. So we get that these two heights must also be equal. This height and this height is the extension. The question I'm confused about is that, so what I'm trying to, if we can prove, if we can prove that BD is a straight line, we are done. Suppose we prove BD is a straight line, I mean BPD is a straight line and APC is, if BPC is a straight, BPD is a straight line, APC must be also be a straight line. Suppose we prove that P lies on the, therefore what is this P? P is the intersection of the diagonals. If P is the intersection of the diagonals, what happens? If P is the intersection of the diagonals, it implies that if this triangle equal to this triangle, so this must bisect and this must bisect. Okay. So, and therefore we get that these two must be these two, all of them must have equal areas. Okay. So it implies automatically. So then it implies if two diagonal bisect each other, it must be a parallelogram. That is automatically also implied. Okay. So we just need to prove that PPC, that is P is the intersection point of the diagonals of points of diagonals of ABC. I think that is provable. Yeah, that's the thing, Nijor, I was asking about. That if we can prove that P lies on the APC is a straight line and BP is a straight line, I think we can prove that using this idea. Or maybe no, I'm not sure about that. Yeah, exactly. No, see, square, rectangle, rhombus are special cases of parallelogram, okay? So if it will automatically imply it is a parallelogram. Here the diagonals bisect each other. So we just need to prove that P is the intersection, P must be the intersection point of the diagonals. Rather, BPD is a straight line. If we can prove that BPD is a straight line, it automatically implies APC is a straight line by symmetry, okay? Just replace it. So can you prove that BPD is a straight line? That's the idea. Can you prove that? Let's try that, I'm not sure. Let's try that. So suppose we are trying to find a point, and let's another one where they're intersecting, such that . this parallel line, this is such a point, and we are also trying to find this such that this is such a point. We just need to prove that this implies that somehow this cannot happen always. We have this equal to this, and we have this equal to this. Can it happen? That's the idea. Can it happen? Just give me a minute, let me think. Hmm. Okay. Okay. Just give me a minute to think. Okay, this is turning out to be a bit longer problem that we can. Yeah, you can also try that. No, wait. Let us assume that BP passes another point on CD. Okay, this is a. I think this is a good idea. Let's see. I think that is a good idea. Let's see this how if it works or not. Maybe contradiction will work. Okay, so we are telling that this must be a midpoint. Okay, on such a point. So if you want to find all such points such that okay, okay. Okay, just let me think about it once. Therefore, what it implies that it must be parallel to this line. Ah, I think we got this. Suppose there's another point for which it holds. Therefore, what we will get? We will get that this is lovely. Thank you so much. I think yeah, Nidja told this. Yeah, lovely. So we know that if we take this point and take the midpoint of this guys, yeah, lovely. Thank you so much for giving this idea. A, B, C, D. We know that CD and its a midpoint P is there for which these two are equal. Okay. We know that such a point P exists. Now let's take another point P dash for that also this holds. And similarly, we know that P dash must be parallel to this BC and P dash must also parallel to AB, which cannot hold. We know that. Okay. Which cannot hold. We know that. Right. So therefore, what we get? We get that P and P dash must be equal. Lovely. Thank you so much. So yeah, you're using the same idea. So it implies that P and P dash must be equal, and which implies that yeah. So we have solved this problem. Lovely. Oh, nice. Thank you so much. So yeah, we have solved this problem that if P is such a point, it should be the intersection of the diagonals. And since the intersection of the diagonals, we have got that it must be equal. The diagonals must be intersecting and bisecting each other, and therefore we got a parallelogram. So if such a point P exists, it's if and only if it's a parallelogram. Thank you so much, guys, for like being through this discussion, interesting discussion. Yep. And I'll see you in the next video. Stay tuned and stay blessed. Don't forget to subscribe to our channel. Bye bye.